For this one, it says the chemical reaction 2NO2Br gas breaks down to give us 2NO2 gas plus Br2 gas. It has an entropy value of 135 joules over moles times K and an enthalpy value of 926 kilojoules over moles. I ask, calculate the temperature when KQ equals 4.50 times 10 to the 5. Now, what we need to realize here is we have to use two equations. I give you delta S and I give you delta H. So what equation connects them together? Delta G0 equals delta H0 minus T delta S0. At the same time, I'm introducing our equilibrium constant K. What equation connects delta G to K? Well, that will be delta G0 equals negative RT ln K. Now we're going to say that both of these equations are equal to delta G0, which would mean that this portion is equal to this portion. So let's make them equal to one another. We're going to say here delta H0 minus T delta S0 equals negative RT ln K. Now, since we're going to need some room to work this out, I'm going to remove myself, guys, from the image so we have more room to work with. So let's plug in what we know. We know what delta H is. It's 926 kilojoules over moles minus temperature, which we don't know. Here you need to convert your delta S value into kilojoules. So divide this by 1,000. So that gives us 0.135 kilojoules over moles times K. R is your gas constant, which is 8.314. But actually, we need to convert it from that number because it's 8.314 joules over moles times K. That's what R equals. It's that constant number. But we need it to be in kilojoules because this is in kilojoules as well as this. So we divide that number by 1,000 to get this new number. Temperature. We don't know what temperature is here either, so we'll just put T again. And then ln K, which is 4.50 times 10 to the 5. Okay, now let's combine like terms. So we're going to multiply this times ln of this answer. So that's going to give us negative 0.108223 T. Because remember, our temperature is still there as a variable. And that equals the other side. That equals 926 minus 0.135 T. We're going to add 0.135 T to both sides. So 926 equals 0.026777 T. We want to isolate temperature, so divide out the 0.026777. And that'll give us a temperature of 3.46 times 10 to the 4 Kelvin. Hopefully you guys were able to follow along when doing this question. And just remember, delta G0 equals more than just one type of equation. Here it equals these two particular types. In order to connect them together to find our temperature, you need to know what those equations are in the first place. And after that, it'll just be simple algebraic methods in order to find our final answer.